Okay. And okay, so today we're looking at radians. And as mentioned, this is an important first lesson of this whole unit. We're going to see radians throughout the entire thing. Okay. But don't be intimidated by it. Radians and degrees are just a way to measure angles. Okay. The difference is degrees we're really used to working with degrees, 360 degrees all the way around a circle. Um, when we deal with radians, we're dealing with the um, the aspects of a radius, a circumference, an arc length, and really all those are going to be related in our next lesson when we talk about the unit circle, because if the radius is 1, then you could figure out all these different refined parts to the circle. And we're going to see, we'll get so into the radians, the unit circle, that you'll be sick of it, but hopefully not. So look, this is just a review, just in case you're feeling rusty with circles. This is a circle. The radius is like the spokes of a wheel, and the spokes of a wheel are exactly the same all the way through, all the way around, right? The S, our arc length, which would be noted this way, right? AC, between A and C if these were labeled. The arc length is actually how far you'd have to walk around the circle to go from here to here. That's just the arc length. It can be measured in, that's like a standard length measurement, like inches, feet, meters, whatever. Same with radius. Those are measured as feet, meters, anything, centimeters, whatever. But the angle is something too that we need to make sure we speak about it all in the same way. It has this symbol here, theta. That's the Greek symbol for theta. So if I'm talking about theta, I'm talking about how far the degree measure is from this radius all around to this radius. Okay. All right, no problem, Stephanie. All right, so that is the breakdown of the parts of the circle. Now, if we're finding theta, theta is the relationship between the arc length and the radius. And we're going to see this later. We're going to see this later when we learn about, the circumference. We've seen this before. The circumference is 2 pi r, right? 2 pi r. And if the radius is 1, this is where we're going with this. If the circumference is 2 pi r and we ended up at the radius of 1, then my circumference all the way around is 2 pi. And that's going to be something really important later. Okay, so this is kind of where we're going. It's mainly looking at, okay, the relationship between the distance all the way around and the radius is related to our circumference formula. But for now, we're going to focus just on finding theta, giving your answer in radians. It's still this relationship between the arc length and the radius, okay? So these things are kind of connected, and in the next lesson, we'll bring it together even better, okay? But theta is going to be whatever the arc length is. So if this was 10 inches, it'd be 10 inches over, maybe this is 3 inches, 3 inches. And you would just work it out. You're going to end up with a lot of decimals with this, okay? You're going to end up with a lot of decimals with radians. Radians can also be expressed with pi in the measurement. So when we get to example 3, we're converting 2 pi over 3 radians. When we start talking about radians, we're always going to be speaking about it with pi involved. And that has to do with our unit circle when we have that radius of 1, because pi is always involved with the circumference, the distance around it. Okay. So these are kind of, I'm sorry that they're a little bit disjointed ideas to start. Where our lesson today is actually much easier. I'm just giving some foreshadowing of what's coming. Okay, guys? So just keep all these things in mind. Just keep them all in mind. But the main thing is, to find theta, we take the arc length and we divide by the radius. And that's what that angle is going to equal. Okay. So I see here, I need to change one thing, guys. I noticed right now. in the scheme of all this, we're not going to make theta out here. I want you just to scribble out that theta out there. Okay. Theta is actually going to be this. And just because if we're trying to figure out and understand, everybody change this right here. Changing that. We're going to mark theta as that internal angle right here. That just works with everything else. I just noticed that right now. Now, this could be theta, but if theta was this angle out here, then the arc length that we'd be interested in would be all the way around the other side, right? That would be the arc length that we would need to be considering. So all this works now the way that I rewrote it there. Now we're in good shape. Now we can do it. Okay. So remember, radians and degrees are just ways to measure angles. And if I'm finding the radians from degrees, the radians are going to be equal to whatever the degree measure is, times pi over 180. Times pi over 180. And the way and reason why this happens is essentially anytime you're converting between units, let me see, divide that there. You are looking at radians to degrees. You don't have to write this. Pi over 180. Now, I'm going to revisit this idea when we get to our next lesson. But the conversion that we're doing is essentially just making a proportion where it's the measurement of the radians is to degrees in the same way that pi is to 180. And I'm going to talk about this part. I just want to kind of show that it's really a proportion, but all they did was, they multiplied by degrees. And then you have that the radian is equal to the degrees times pi over 180. It all has to do with the proportion here. This proportion is going to be something too that we keep revisiting when we look at the unit circle. So finding the radians from degrees and finding the degrees from the radians is just a matter of manipulating this proportion. Okay, it's just manipulating this proportion that relates radians to degrees in the same way that pi relates to 180. Okay, keep all that in mind. What we actually have to accomplish, like for homework for today, is actually much easier. I'm just trying to front load for what's coming up. All right, so for finding degrees, it's going to be the radians times 180 over pi. So that's the only switch that we have to keep in mind. That's the only switch. Okay, so now let's kind of zero in. Let's go ahead and find theta in radians for this guy. And we need to go back and remember that theta is equal to arc length over radius. So go ahead, you're gonna need your calculator. Go ahead and grab your calculator if you don't have it out, because we're gonna be dealing with the calculator work here. And let me think about this. Okay, no, this is fine. There's going to be a moment when we switch between modes, because if you look on your calculator, there's degree mode and there's radian mode, but that doesn't come up right here yet. Right now, we're just dealing with the pure ratios. So I need to go in here, and I need to figure out what theta is. Theta between, it's this angle ABC. I need to find what that theta measurement is. And what I know is, I know this arc length between A and C, AC is 19 inches. I know my radius is 7 inches. So, and I need to go and put those in there. I'm going to go ahead and let people in the chat let me know what is our final radian measure going to be. And you could label it, like if it's 2.3 radians, you could do 2.3 rad, RAD. RAD is how I'll be talking about radians moving forward, RAD. Okay. So I'm going to go ahead and put the arc length on top. I'm going to put the radius on the bottom. And I'm going to divide them. All right, somebody in the chat, let me know how many radian measures do we have? How many radians? Yep. Give it to the hundredths place, just like money. Just like money to the hundredths place. But yeah, you're right, Josh. Joshua. All right. 19 inches divided by 7 inches. The units are going to cancel out. That's nice. And we end up with 2.71 radian. That's our answer. Okay. So we're just doing the basics with this. So far, so good. Yeah. Yep. Okay. All right. Next, we need to convert between degrees, 78 degrees, and radians. So that's where we got to go back up here. We got to get our conversion formula down. Finding radians from degrees. It's going to be the degrees times pi divided by 180. And you know what we're going to do is, watch. Let's set it up this way. The radians is going to be 78 times pi over 180. But let's leave pi in our answer because radians can be expressed with pi in the answer. Just like over here, you see how pi is in the answer. So what you can do is you can just deal with this 78 and the 180 because it's going to be 78 divided by the 180 and leave pi in your answer. Leave pi in your answer. It wouldn't be wrong if you found a decimal, and I could find both for us. But we're going to get used to leaving pi in the answer. And you'll see why when we get to next week. Okay, so we'll actually label it theta is equal to, now if you would have multiplied it all together, you would get 1.36 radians, but that's not what we're going to do. We're going to just divide 78 divided by the 180. You get 0.43 pi radians. Okay, so both these are right, but we're going to get used to leaving it in terms of pi. You could have reduced that, I guess, but no, you're going to end up with a decimal pi. It's just going to be helpful for us to leave it in terms of pi for the unit circle that we'll get to. All right. And finally, convert 2 pi over 3 radians to degrees. So I'm going to go ahead and set up theta is going to be equal to, let's see, we have it right here, finding degrees from radians. You put your radian in there, 2 pi over 3, and we're multiplying it by the fraction 180 over pi. You see, go ahead and cancel out what you can before you take your next steps. And then I want to see the answers. Let's see the answers in the chat for this. What do you get for the degree measure? What is theta in this case? Nice, Sonia. Anyone else? Dave, double check your work. Remember, it was 2/3. This is 180. Pi's are going to cancel, but how does the other parts come in? All right, everybody give me their measure in degrees in the chat. What are we going to get? I'm seeing a couple different answers, so maybe I'm thinking about it wrong. Let's see. Oh, wait a minute. Okay, Dave, you're right. Ziamato, you're right. Sonia, I misled you. We also had to multiply by 2. Took the first answer and I was like, that has to be right. And I didn't look close enough. All right, let's see. We have 2 fractions here. We can cancel out our x's, our pi's. All right, and then I look here, 2 times 180 is 360. 2 times 180 is 360. Divided by 3, 120 degrees. Straightforward. Okay, let me think if there's anything else I want to throw in about this. Nothing really. Guys, I'm gonna give you a lot of extra time today. Just knock out the homework. Honestly, it's doing a bunch of conversions, finding the radians. If you thought these 3 example problems were pretty straightforward, just knock it out. Honestly, I think it'll take maybe like 20 minutes. Okay? All right, let's get a final vote. Thumbs up, sideways, down. Thumbs up, sideways, down. Thumbs towards me or away from me. Spinning thumb. All right, that's a lot of thumbs. I think we're good. I'm gonna stop the video and